Hi, I'm Alan. We're out at the range again today to do some more armor testing. Now, last time we tested the concept is known as spaced armor, where you have multiple armor plates separated by a small air gap in between. Today we're going to be doing some additional testing along those same lines. We're going to start with a test that I didn't get a chance to do last time. We started last time with a 3/8 inch steel plate. Now 5.56 punched straight through that plate, whereas 7.62 stopped on that plate. At the end of the test, we took that 3/8 inch plate, put a thin 1/8 inch saw blade piece in front of it, shot that, and instead of going straight through, 5.56 was totally defeated on that steel plate. Punched through the saw blade, but stopped on that 3/8 inch steel. Now today, one of the first tests we're going to do is we're going to take that 3/8 inch steel plate and put a saw blade behind it. So when the 5.56 punches through that 3/8 inch plate, we're going to see if it has enough energy to still penetrate that thin saw blade behind it. This is testing to see if the arrangement of the armor in spaced armor, the arrangement of thick and thin plates, how much that matters in terms of armor protection. The next test we're going to do is to test a 5.56 and 7.62 against a full 1/2 inch thick steel target. Now I have this guy. This is a railroad tie plate. It's roughly 1/2 inch thick. It might get a little bit thicker on this side. However, it's going to be roughly 1/2 inch, which should be the combined total armor thickness of that 3/8 inch plate and that 1/8 saw blade. We're going to see if the 5.56 can punch through this or if it's defeated. This is going to tell us whether the spaced armor concept is really valid or whether it's simply overall thickness that truly matters in armor protection. Finally, we're going to test against one of these guys. Now last time we had a stack of saw blade plates like this, where each of the plates was spaced out about 1/4 inch. Now today we're testing with all of these plates jammed up against one another. Now, so this is going to see if the spaces between the plates really matter, or whether it's simply, again, overall thickness of armor. In our previous test, 5.56 went through 6 saw blade plates, or stopped on the 6th plate, whereas 7.62 by 39 stopped on the 5th plate. Our rifles today are a direct impingement PMAG adapter chambered in 5.56, and an AK pattern rifle chambered in 7.62 by 39. Both of these rifles have 16-inch barrels, and the targets are at 30 meters. The rounds I'm going to be shooting today, much like last time, is a 55 grain 5.56 by 45 M193 full metal jacket, and a 124 grain 7.62 by 39 full metal jacket. Okay, so let's take a walk down range, take a look at this first target, and get started with this test. Here we are down range. We have our 3/8 inch thick steel plate sitting here. Now, this hole right here, straight through and through, was a 5.56 shot from last test. It went completely through this 3/8 inch mild steel plate. Now, behind here, we also have a saw blade. Now, when we did this in the previous test, we had a saw blade sitting in front of this piece of armor, and the impacts, when it went through the saw blade, only cratered the surface and did not totally penetrate like they had before. So today, we're just going to test to see if we have a saw blade behind this piece, whether the bullet will penetrate both the steel plate and the saw blade, or whether it will stop on this saw blade. So in my setup here, I'm making sure to leave a little gap between these two plates, which is the space in spaced armor. And what we're going to find out is whether the arrangement of the thick plate versus the thin plate affects overall armor value. So let's go shoot at it. 5.56 against the 3/8 inch steel and saw blade target. All right, here's that steel plate There's a few extra holes in it. Now I tried this test with a couple extra shots just to make sure. Notice there is not a single hole in this saw blade, but we definitely were penetrating that steel plate. Now there's a few small dents in it, and from what I can tell is that we have here the shiny lead of a bullet totally encased in a little bubble of steel. So the conclusion for this test is that a 5.56 round will totally penetrate this 3/8 inch steel, but when it comes through, it's now pushing a big bubble of steel in front of it, and it's exiting the steel with a much lower kinetic energy and in an extremely ballistically inefficient way, so that it will stop on this saw blade and simply dent it. What's happening here, or what's on display here, would be that this saw blade is acting like the spall liner on the inside of an armored vehicle, so that rounds that can penetrate the armor and come through even slightly will come through ballistically inefficient with much lower kinetic energy, but will still be flying off the back of this plate at a dangerous speed, we'll say. But this spall liner, or the thin armor on the inside, would prevent those splinters and fragments from damaging the crew. And it actually doesn't need to be that thick or intense because they're coming through with low kinetic energy in a ballistically inefficient way. Well, let's go on to testing with one of these big 1/2 inch railroad tie plates. We're going to shoot 5.56 and 7.62 by 39 at it, see what happens. This is the 5.56 against the 1/2 inch railroad tie target. Alright, here's that 1/2 inch railroad tie plate target. Nice big hit right there. Now it did not penetrate, but man did it try. Got a little mushrooming and a dent right there on the back, and a big old crater right on the front here. Pretty neat. Let's hit this with 7.62 by 39, see how it fares. This is the 1/2 inch railroad tie plate target for 7.62 by 39. So this is after the impact of the 7.62 by 39. There's our 5.56 shot. There's my first 7.62 by 39 shot, but it was hitting on this extra thick section here, so I decided to try another. There's a real good one, square in the center of this 1/2 inch plate. Now you can see it left a nice big crater there, though that 5.56 crater's substantially more serious. And if we look at the back, got a good old crater there, or just sticking right up top. Alright, now just for the heck of it, I've decided we're going to try this railroad tie plate target in a spaced armor configuration. So we got our plate here. Now this section up here is actually a little thicker than it was down here. This was 1/2 inch, and this is maybe getting close to 9/16, maybe possibly even 5/8. But we're going to slap one of those saw blades on here. We got a little space right there. We'll plug this with both 5.56 and 7.62 by 39 and see what that plate looks like on the other side. Alright, this is the railroad tie plate target with a spaced armor saw blade right in front of it. 7.62 by 39. This is the tie plate and saw blade spaced armor test. We got a hole blown clear through this saw blade with a big old 7.62 by 39 round. But what's that? Just this barest little dent in the steel. Yeah, nothing on the back. I bet that round's somewhere in the dirt down there. Let's take a closer look at that. Yeah, I mean, you can see it just barely dented that plate after we added just a thin saw blade in front of it. So there's 7.62 by 39 with a spaced armor plate. There's 7.62 by 39 without that spaced saw blade plate. Let's give this a go with 5.56. Alright, this is the 1/2 inch railroad tie plate target with a spaced armor saw blade sitting in front against the 5.56. Okay, this is our target after that shot with the 5.56. We got our little entry hole right up here that punched just straight through that thin little plate. And wow, look at that. This is the impact it left and just splattered all of that lead and all that projectile just atomized right on that plate right there. Look at that. Wow. Now again, left a nice little crater in there, but as we can kind of see here, that's our shot with 5.56 with the spaced armor in front of it. And this one here, that nice deep crater, is the shot without that spaced armor plate. So the spaced armor definitely makes a difference in damage to the plate behind it. Also, on this one, you can see how that first 5.56 shot without the spaced armor, the jacket is just sticking out, welded onto the front, whereas that jacket is not at all present on this shot. Well, that's pretty neat. Okay, so there's one final test I want to do against big, thick railroad tie plates like this one. Now, this is the thickest piece I was able to find, and it is along that edge easily 5/8, if not approaching 3/4. So this is a pretty hefty piece of steel, and that's approaching, I mean, vehicle armor in military vehicles. If it's hitting 3/4 of an inch thick, that's relatively reasonable for some light armored vehicles. So we're going to test the 5.56 and 7.62 against this, see how it does. Maybe throw that spaced armor plate on there, see what that does as well. Alright, this is the 5.56 against the 3/4 inch thick railroad tie plate. Alright, the reason you saw me take 2 shots there was I didn't see this plate move in my optic, and so at first I thought maybe I missed it, but nope. I hit it both times right there and there, but it's such a big, thick, heavy plate, it wasn't moving around on us. Now, look at this. Okay, there's those 2 impacts. That one, well, they look maybe from the surface 1/4 of an inch deep, perhaps. And definitely did a number to the steel, but shoot, this big thick plate is still doing pretty good. Now what's impressive is none of this has been armor grade steel. Look at that, there's not even deformation on the back. None of this has been necessarily armor grade steel. It's not AR 500 or anything like that. And the rounds that I'm using are not armor penetrating in any way. They're just regular FMJ. So I would say that is perfectly adequate if you want to stop 5.56 fire. Let's zing a couple 7.62 by 39 into this to compare. Alright, here we got 7.62 by 39 versus the 3/4 inch steel plate. Alright, looks like my first 7.62 by 39 shot hit kind of low and skipped right through that hole. But the second one was a pretty good impact. Now it's not looking as serious as that 5.56. And actually, that looks about like the 1/2-inch plate looked after we applied the space armor to it. Maybe. But I think it's pretty definitive. If you got a piece of steel this thick protecting you, you're going to be pretty okay. Now, it doesn't look like there's any spalling coming off the back or anything like that, and I don't see a single divot. Okay, these are our final targets. Now, these are made each with a whole series of stacked together saw blades on a piece of all thread held together by a couple big nuts. Now, there's no space between these plates, and I measured both of them, and they both equal 1/2-inch thickness in total. So, we're going to shoot 5.56 at the one on the left, 7.62 by 39 at the one on the right. All right, there's the 5.56 against the stack of steel targets. And this is the 7.62 by 39 against the stack of steel targets. Okay, here's the results of our test. We have our other 1/2-inch target for comparison. Here's 5.56. Looks like we do not have penetration of this, but man, I can tell this back plate is bulged. And look at those impacts. They go in a ways, but they definitely didn't penetrate this guy. Okay. And here's 7.62 by 39. Now this was my first hit. Again, we get a little deformation on the back. Not nearly as bad as the 5.56, which totally punched through at least one of these plates completely. Whereas the 7.62 by 39, it didn't punch through this at all. It just kind of smashed into it. That's really fascinating. That these thin little plates all stacked together, 7.62 by 39, didn't actually penetrate any of them. It just kind of smashed into them really hard. Now compare that to the impacts we got on our 1/2-inch steel plate, and it's actually a pretty different pattern. That's pretty fascinating. Well, let's pull these guys apart and just see what they look like on the inside. Okay, here we have the pack of plates that was hit by 5.56. We'll try to get this on video as best I can. Now it totally penetrated this first, and then on all the subsequent plates, it did not penetrate. It just left increasingly shallow craters as we go further and further back through this stack. So we get to the final plate, which just has these couple of rather benign looking divots. Fascinating. This is especially fascinating because in my previous video, when we had all of these plates spaced out about 1/4 of an inch, the 5.56 would actually penetrate the first 5 plates and stop on the 6th. Well, what's interesting here is we have 6 plates in this stack, and it only penetrated the first one, and the rest are simply dented. Okay, so this is a stack of plates that was hit by 7.62 by 39. Now you can see on the front, those aren't even penetrations. That's just the round impacting this thin steel plate without penetrating. Now as we move back through our stack here, you can see that each one of these gets progressively less dented as we go back through this stack of plates till we get to the final one, which kind of just has a little scuff mark on it, barely deformed there. Wow! So when we did this with the plates spaced out in an arrangement similar to that, the 7.62 by 39 punched all the way through 4 whole plates and stopped on the 5th one back. Whereas this, like this, packed together, it didn't even compromise that first plate. So my theory as to what's happening here is that when all these plates are squished together, they're not solid steel still. And so when a round impacts, each plate deforms back slightly, hits the plate next to it, that plate starts deforming back slightly, the next plate back from that starts deforming even slightly, and almost acts like a big spring or a big sponge that just soaks up that kinetic energy without actually letting any of the plates become totally penetrated. Now 556 has a smaller cross-sectional area and is traveling much faster, higher kinetic energy, so it's able to punch through that first plate. Now notice how that first plate on the 556 isn't even dented. That's because it's hitting that, traveling so fast, it punches right through that first plate, and then only on the second plate in that stack do we start seeing what I'm going to just assume is sort of this spongy effect, where all of these deform together as a mass and just soak up that kinetic energy. All right, well that was pretty fun. Let's do some quick conclusions here and see what we learned over the course of all these tests. Alrighty, let's start with our 3/8 inch thick steel plate. Now, we knew going into this that a 556 will punch straight through this mild steel plate. However, like our test last time showed, when you put a plate in front of it, it totally stops 556. Now, when we put a plate behind it, again, the plate itself will be defeated, but the plate behind it will not. Now, when we shot our 1/2 inch steel plate, we found that 556 and 762 by 39 would not penetrate, and then when we added a spaced armor sheet in front, we found the penetration got even less. Now, of course, going on to this big, thick guy here, just was totally fine getting hit by both of these rounds. Moving on to the stack of pressed steel plates, maybe you could call it, we found that even though it's a 1/2 inch total thickness, they both were still very effective at stopping both 556 and 762 by 39. And in fact, the stack of plates like this, with the same number of plates, was substantially better at preventing penetration by both 556 and 762 by 39. Alright, well I hope you enjoyed this video. It was certainly fun to come out here and shoot at all these targets and just test different ideas about vehicle armor. It's something I've been interested in for a very long time, and now I have a little bit of first-hand knowledge. There's a link to some Aberdeen Proving Ground testing material below that goes a lot more in depth on all of these concepts, and definitely check out my first video, which I'll also provide a link to in the description. Thanks, and have a nice day.